Now we continue our coding with the core multiplication that we are sharing. So we multiply the multiplicand wire with multiplier wire and keep it in this very short wire, which is extended to add 8 bits more in the fraction part, like this. And then we declare with the extra 8 bits. Next, we shift the product wire with extra bit to the right by 8 bits so that we can maintain the 16.8 fixed point notation, like this, and then we declare it accordingly. Next, we arrive at the two registers to keep the two products that later we will divide. So a register needs to be coded in always block. So this is the code. Pay attention to the negative edge of clock because we are standardizing. Everything in data unit will be triggered by negative edge. And the loading of the two registers will be done when the respective load signal is 1. Then we clear the registers and initialize accordingly to 0. We have made a considerable change already. So let us save and compile to make sure that we are still on the right track. 2 errors. Load 1 and load 2 has to be declared in control unit, like this. Next, we need to extend the wire that is coming from product 1 to prepare it for the final division to get F. This is the rule for fixed point division, like this. Then declare it accordingly, like this. Then the last step in the data unit is to get the division that we want to go to the output F, like this. Let us save and compile again. Next, we continue to code the control unit FSM. We have done the first state where the start is 1 and we force any current state to go to fetch 1. So next we are going to code what to do during fetch 1 state, which is to go to fetch 2 as next state, first or second to become 1, loop 1 0, loop 2 1, stop still 0. Actually, we have not coded the other condition here, so we need to add it first. So this is the complete state and output assignment for the state where start is 1. So we need to declare stop as register. We need to declare state variable. And we also need to declare parameters to replace with some constant. This is the declaration of stop as register. And this is control unit state register. We initialize to fetch 1. And this is the declaration of state names as parameter. Now that we have declared everything properly, we can continue in control unit FSM. Now we want to do this as switch case. So case of state, we have state value as fetch 1, fetch 2, and done. Each of these should have begin and end. Then we copy the same set of value that we set in this block into each of the state. Remember that you need to assign the same value in every block that you make assignment under the same always block. That's it. Then we need to edit accordingly. Remember, we just copy and paste. First or second, after start need to be always 1. Like this. Load 1 always 0. Load 2 0 at the beginning and then 1 0 0. Stop will only be 1 at the end. Then the next state from fetch 1 is fetch 2 to done, done to done. We have done so much. Let us save, then compile. Still looks okay.